Okay, so a couple quick things. The topics are due by Sunday night. The test will be on Tuesday. The practice test is already up there, so you can practice the 20 questions. It is basically designed as a homework assignment. So what that means is you can do each question multiple times. Even if you get it right, just like here on the ones that I do up here, you just click try again, you can get another problem that's exactly the same. The one that you're gonna have a class is the same thing, it's just gonna be a printed version of it. So, yes.
Monday.
Oh, it might be, you're right, it is Monday night. Second part of that, I'm gonna tell you in a second, which will take some of the stress level off people. I don't put in your 40%, the course completion percent, until the end of the course. Okay, which means that come Monday night, yes, chapter 0 and 1 will lock, chapter 2 will unlock Tuesday morning. That does not mean that you cannot go back towards the end of the semester, or that you can't finish those topics because they're prerequisites for other topics. Okay, so if you do not finish all your topics, it is not the end of the world. You still have the ability to go back and do those later on. All right, to fill that in. So basically at the end of the semester, I'm going to look at your complete pie percentage of what you've had done. That's the percent that I'm taking. Okay, so if you miss a couple here and there, it's not the end of the world right now. You can catch up. And the later goals are going to be a little bit smaller than the first one. 0 and 1 is big because it's a lot of prerequisite skills. But the later goals will be a little smaller, and you might be able to finish those quicker. And once you finish a goal, if you finish all the topics in it, everything unlocks. So you can always go back and fill in those other ones that you missed. Okay, so don't freak out. It's not the end of the world. Yeah. I can make it available for you in 3 months. Yeah, I've got it set so that it will stop after Tuesday, but I can easily change that. That's not a big deal. Yeah, so one of the things that Alex does, the way it's designed is it's going to constantly give you those knowledge checks as you're going through and doing them. So if for some reason you forget something, it'll give it back to you. As much as you don't want that, but that's actually kind of one of the things that it does, is it kind of constantly reinforces those skills that you go through. And just like I have a practice test for this one, I will have a practice test for the final exam too. So you can go through and look at those, that thing as well, to practice that before you take the actual test, which I know is what some people are worried about at the end. And I understand that. Sure. So there's a couple topics towards the end that I'm not going to get to. There's some word problems that I'm hoping to be able to get to towards the end of class tonight. I know it's not on this list, but I know I didn't get to them last time. And there's a couple of geometry type questions like area of a piecewise function, stuff like that. I'll have to look. All right, I'll look in a minute. So let me finish. Let me go through the inequality ones, which I know I haven't seen yet, and then if we have time towards the end, I'll pick up some other topics that we could possibly do. So I'll look at the list and see if there's topics that a lot of people are still missing. So, all right. The only difference between tonight's class and the one we did before, we're going to have inequality symbols. So inequalities we have less than and greater than. So it's less than and greater than. And then we have less than and equal to and greater than or equal to. And greater than. Okay, so those are the 4 inequality symbols. There actually is one more, you just rarely see it, and that's that one. And that's it's not equal to. That's the other one you typically see. Well, yeah, that's the equal sign. but that's not considered an inequality. That's called inequality. Depending on when you graduated high school and when your teacher taught you, you were either taught the Pac-Man was eating the bigger things, the alligator was eating the bigger things. Yeah. It's like, that's the thing you got to look at, right? The mouth. Think about it as a mouth, and it's eating whatever the mouth goes to is the biggest thing. So that's the most important part. All right. That's not what I wanted to do. Just wanted to move this up. There we go. All right. So 5 is greater than C. So 5, just like I said before, the word is typically an equal sign, but that's really the break point. Is greater than, so greater than C. As it. So 5 greater than C. I think you can use the keys on the keyboard. Yeah, you can use the keys on the keyboard too. So I don't know. I want to see something real quick though. Yeah, you can't do the greater than or equal to though. On the thing, you actually have to use the buttons for that one. Make sure you use the right variable that they're talking about there. Yeah, otherwise they'll yell at you. Sometimes when you're looking at problems like these, when you're doing it, think about a realistic problem. So Karen exercises no less than 40 minutes a day. So give me a number that she would exercise. What number is no less than 40? 41. So 41 and 40. Which way is the symbol going to go? 41 is bigger than 40, right? That's how you think about it. All right. And no less than means it could actually be 40. So we put that there. So in this case, we're going to use it's t is greater than or equal to 40. Because a lot of times when you sit there and say, oh, it's the less than's there, and it's like, okay, I'm going to put that symbol that way. It's like, but read the problem and think about a number that makes sense for that, and then put your symbol in, and you won't make those mistakes. So this one is t is greater than or equal to 40. And then the next one, the temperature inside a lab refrigerator is less than 40. Give me a temperature for the lab fridge. 39 or 30. It doesn't have to be exactly lower. It could be any number lower. So 30 obviously is going to be less than 40. So this is t is less than 40. So use that process to do these problems, and I think you're going to be a lot easier off doing them. All right, so now these, actually, we're going to go back to these. So on this one, you basically are going to go the direction that the arrow is going in, which is kind of nice, but I'm going to show you it. I'm going to give you the actual real way to do it. But we want to look at one more thing. Less than and greater than will be an open circle. The equal to ones will be a closed circle. Okay? So less than and greater than will be an open circle. Less than or equal to or greater than or equal to will be a closed circle. So that line underneath the symbol tells you if it's an open or closed circle. So in this case, it's going to be an open circle. So click the open circle, and I'm going to click at 10. Now, we have to figure out which direction I'm putting my line. Just like we did the last problem, I always choose a number. Okay? I always pick a number to do it. So in this case, and I always typically pick 0. So I would say 0 is greater than 10. Is that true or false? That's false, right? So that means right here at 0 is wrong, correct? So that means I've got to click the other side. Okay? So I always choose 0 and try it. If it works, I click where the 0 is. If it doesn't work, I click the other side.
I look at it like a number, like if it's going like better, it'll be on the right side, and if it's going
What side's that on?
The numbers criteria would be going.
Okay. What side's that one? Okay, that's fine. The way you're doing it works. Because normally what people look at is they look at the direction of the actual little arrow.
Yeah, I look at it.
That's fine. No, that's fine. It makes as whatever way works for you. That's fine. So I like the testing because it works not only for these, but it also works for the graphing and shading and stuff like that later on too, which is quite nice. So.
That's just how I look at it.
Yeah, no, in your way, it totally works. I wanted to make sure that's why I gave you a couple more because I wanted to make sure what your thought process was made sense. Shaded circle is equal to once. Less than or equal to or greater than or equal to. Yeah, that's the shaded ones.
We always see it as like the letter being always on.
Yeah, that's fine. All right, so these, we did one similar to this one before. It was the equal sign one, where we're just plugging the numbers in. And if you remember it in that one, I told you could solve it to see if it worked out. And then just if that number was there, that'd be the yes, and there was only one yes. In the inequalities, that doesn't work because we could have all of them be yes. Okay, so you actually have to plug the numbers into these and try them out. So I'm gonna plug in a couple of them. I'm not gonna plug in them all. So 5, 9 plus 6 is less than 36. What's 5 times 9? 45 plus 6, 51 is less than or equal to 36. Is that true or false? So that'd be no. We have 5 times 6 plus 6 is less than or equal to 36. 5 times 6 is what? 30 plus 6 is 36. So I have 36 is less than or equal to 36. Is that true or false? That is true only because of that line underneath it. If that line was not there, this would be false. Okay? So just keep that in mind. And then actually 2 and 6 both, 2 and -8 both work too. So just keep that in mind, that only works because of that little symbol right there. Right, so just little thing to keep in mind. All right, solving the problems. When we're solving these problems, the answer, the process is identical to when we solve it with an equal sign, except for one thing. And when we get to that one thing, I will show it to you. It's not actually in this problem. So what's the first step I got to do? Minus the 6, right? No different than we did before. So -16 is less than or equal to v. I'm done. The one big thing with these is don't switch them around. Don't just automatically put the v first. Because if you switch it around, you have to switch everything around, including the inequality symbol, which means you're probably going to mix it up and not put it in the right order. Right. So whatever you get as the answer, write that answer directly in that same way. So -16 less than or equal to v. Actually, I'm going to skip this one for a second. We're going to come back to this one. I want to do this one first. Actually. All right, so let's look at this one. Go through my steps. What am I doing first? No parentheses, no combining like terms. So I got to move variable, right? Which one am I moving? Right. Why am I moving the -9v? Right, remember I said, always move the smaller one. So I'm going to add 9v to both sides. So I have 2 is less than or equal to 14 plus 3v. Next step. Right, so move the 14. So negative 12 is less than or equal to 3v. Ooh. Divide by 3. So I got negative 4 is less than or equal to v. And that's my answer. Now, I can't remember your name. You just said something very important. Don't I have to flip it? If you remember back from high school when you did these, your teacher at one point said you have to flip inequalities. You do, but in a very specific case. I'm going to actually do the same problem again. We moved the 9, right? So if I don't move the 9, so 2 minus 9v is less than or equal to 14 minus 6v. I'm going to move the 6v. Still same steps, right? Nothing different. We can do that. We did that in the other problems. So 2 minus 3v is less than or equal to 14. I'm going to subtract the 2 from both sides. I get negative 3v is less than or equal to 12. I divide by negative 3. And I get v is less than or equal to negative 4. Are those two answers the same? No. On the first one, v is greater, right? On the second one, v is less. I did all my steps correct, right? The only step I didn't was the very last one. In an inequality, if you divide by a negative sign, you have to switch the symbol. You have to switch the inequality sign. So this symbol, because I divided by a negative 3, becomes greater than or equal to. Okay? That's one of the big reasons I said always move the smaller one. You will never have to deal with that when you have variables on both sides if you always move the smaller one. I'm dividing by it, actually. So that's the thing. That's the reason why we have to switch the symbol. Because when we divide, it changes things up, that negative sign. So to keep consistent, no matter which direction you do it, you have to switch the symbol to keep this problem correct. So whenever you're dividing or multiplying by a negative, you have to switch the symbol. Okay. Now we'll go back to number 6, which was an easy problem, but you had to switch the symbol, and I wanted to explain why. No problem. It's one of those things that we.
I know that I've made that.
Yeah, and believe it or not, teachers, and I'm adding myself into this completely. We've always done problems like this first and say, hey, just switch the symbol. When you divide by negative, you just switch the symbol. Actually, in all of my years teaching, I think I've only actually done that part right there, explained it maybe a couple times. And when I was looking at the lessons and I was driving down, I'm like, you know what? I think that's actually probably the best way to do it, because I think you actually then understand why you're doing it instead of just learning the rule and doing it. So that's why I did it. So, sometimes driving and thinking is a good thing. All right. So we've got 18 is less than negative 2y. So this one, we can't obviously make it positive. Well, we could. It's going to add a bunch more steps we don't want to. So we're just going to divide by the negative 2. So 18 divided by negative 2 is a negative 9. We divided by a negative, so I have to switch that. So negative 9 is greater than y. Okay. I love how Three Rivers calls me knowing that I'm physically in the building. I'm like, you could have just stopped by and said hi. but you know, it's fine.
They don't wanna move the-
It's like, I'm here, can't answer the phone, I'm kind of working at the moment. All right, next one. -3 is greater than or equal to 2x minus 1. What do I do first here? Yep, so I'm going to add the 1 to both sides. So -3. Nope, not -3. -2 is less than or equal to 2x. Next step. Divide by 2. So -1. Do I switch the symbol or keep the symbol? I keep the symbol because I divided by a positive. Yeah. Only with the variables. Only with the variables. And you only ever want to do it when there's things on both sides. Right. Because if I moved the 3, which would be the smallest, I'd end up with 0 and I'd have to still move the thing back over. So it wouldn't help. So yeah, you only do it with the variables because the variable then dictates which way you're going to move the number because you want to move it away from the variable. So -1 greater than or equal to x. All right, so I've got, I swear to God, they actually do put the W's in the letters in the beginning of the problem. Every one of these seems to be the other direction now for some reason. I don't know why. All right, so -14 is greater than or equal to -44 minus 6w. What's first? -44, I'm going to add it. So I've got 30 is greater than or equal to 6 or -6w. Don't lose your symbols like I almost just did. What am I doing next? I want to divide by -6. So I get -5. Do I switch the symbol or not?
Switch it.
I switch it because I divided by a negative. That's really honestly the only step that's different than the equations that we did on Tuesday. All right, so I think there's 10 and 11 both word problems. Yes, 10 and 11 are both word problems. Hello? Hello? Oh, okay, because I'm actually here in class tonight. So, and I saw the number come back up, I'm like, all right, I'll answer it this time. Yeah. Okay, sounds good. Awesome, thank you. Bye. Thank you very much, bye-bye. I figured if they're gonna call me back, then they might need me, so I'll answer the phone. I have a student transferring into one of my other classes and they needed permission to do it. And then she realized I already gave her permission, so I sent her an email. So it's fine. All right, we're gonna actually do this way. I don't need it that way, I want it. Yeah, there wasn't as many problems with this one. Yeah, this one was a little less. All right, so this is going to start because we'll do some more word problems afterwards, and I'll look at the list and see if there's any other major or crazy ones that I want to do. So the last 2 word problems, these are actually inequality word problems, but it's the same process as the equation ones. It's just with an inequality symbol. So there's not going to be a major change in how we're setting these up. So this one, when you're looking at it, we want to set up an equation first. So whenever we have 2 pieces, The total is going to be at the end. Anytime you see the words per or each or things like that, that's typically multiplied by your variable. Monthly fees, things like that, are things that are just added. It's just one-time charge, so you don't have to multiply those by anything else. Yeah, so in this case, my total is going to be 6272. That'll be my total. Then it says 0.04, so 0.04 per minute plus $20. So any questions with where that all came from? Good with that? So now we just got to figure out which symbol it is. Now we know this one's not an equal sign, it's an inequality. So it says the least she has been charged in a month is $62.72. So does that mean her bills are normally higher than $62.72 or lower than $62.72? Higher, because if that's the least she's been charged, they're obviously going to be higher. So that means my bill is greater than or equal to the $62.72. Okay? Yeah, some of them. Like, there's been a couple that I've seen, but most of them do have the equal to symbol in there. So again, just like we did that one topic or that one question back a little bit ago where it was like, what's the temperature in the fridge and those things? Just think like word problems are realistic. So think realistically about what would work and then make the symbol fit for it. Okay, that's literally the easiest way to do this. All right, think realistically. All right, so now, not that any of you pay per minute for your phone calls anymore. That's an old time thing. My first couple cell phones, we had per minute. And then it was like, you got unlimited minutes. And I was like, oh my God, this is awesome. So it's like, you got unlimited minutes. But then at the beginning, it was only after 9 o'clock. And you had to wait till 9 o'clock to call your friends. I don't think I've used a payphone. I got my first cell phone in 1995. So.
You're talking about on business stuff.
Yeah.
We had to put in more coins
Yeah.
for a certain amount of time.
Very, very few. We had one in the corner of my street actually, but it was taken out like 6 months ago. It was kind of funny. It's like, no, they literally took it out because that's where all the drug deals were happening. So let's go through and finish solving this one. What do we get rid of first? Slightly off topic. What do we get rid of first? The 20. So I'm going to subtract 20 from both sides. Yeah. So it's 42.72. The nice thing is when you're doing these, decimals aren't too bad to use your calculator for. So just use a calculator, and they typically will give you a calculator in these topics. So not the ones with the decimals. They normally give you on the decimal ones. Yes, there's word problems without it because they're whole numbers. But if they're asking you to do decimals and stuff, they typically give you one. But you can use a calculator on any of these topics. So I'm not worried about that part. And now we're going to have to divide by the 0.04. So M is greater than or equal to, I can't do this in my head. Huh? Because there's no negative. That's how. 1,068 minutes. Yeah, they need to update these topics a little bit because it should just say additional 0.4 cents per text or something like that because not everybody gets unlimited text, or per gigabyte. We can do that one too. So, all right, so 1,068 minutes. When you type the answer in, you have to make sure you put the whole thing in, including the symbol, because these are the inequalities. So M is greater than or equal to 1068. Make sure to use the right inequality, the right variable for it. They're talking about M in this case, so use M. It might. I think it might. All right, so this topic is actually the same thing, except you're going to have both of them. And actually, I want to see if I can get a different version of this one. Ah, nope, I did get the different version of it. Very good. I like this version better. Nah, I'm not really worried about that one at this point. All right, so in this topic, you're typically going to have two plans, and you got to compare them. So I normally always just set up both of them separately. So Plan A, and they said Plan A is $20.07 per minute. So 0.07 M plus 20. And then Plan B, in this case, is 4 cents a minute, so 0.04 M plus 2660. Also, if you notice in this one, it says 4 cents and 7 cents. I wrote them as dollars and cents. If you put 7M, it'll be totally screwed up. Okay, so just make sure your units are the same. The $20 is in dollars, so the 7 cents has to be in terms of dollars. Now, the next part of the question, once you've got the two, it'll tell you which direction they want it. So in this case, for what amounts of monthly phone use will Plan A cost less than B? So I want. You can. It doesn't actually matter, though. That's fine, except that's not always what they're asking for. In this case, they're literally saying which plans were A less than B. They're telling you the direction. You don't have to guess. They're telling it to you. You want to know how many minutes, because these are both linear equations, so they're going to cross at some point. So after that point, one's going to be bigger than the other one. Before that point, the other one's going to be bigger. So they're telling you which direction they want it to figure out the thing. So it says Plan A costs less than B. So I normally write A is less than B. And now all I'm going to do is I'm going to replace A and B with the equations. So 0.07 M plus 20 is less than 0.04 M plus 26.60.
I remember there was problems where you just had to figure out which one.
So no, this topic they always tell you.
I didn't know.
Yeah. So everybody understand what I did there? Yep, I found the two equations and plugged them into there. So now I got to solve it. But so which one am I moving? The ones with the variables, the 4 or the 7? The 4. So I'm going to subtract the 0.04. 4 is less than 7. 4 cents is less than 7 cents. And remember, I always move the smaller one. Yep. And I'm using that one because it's smaller than the other one. So I have 0.03 M plus 20 is less than 2660. And now I'm going to subtract the 20. So I got $6.60. And then I divide by the 0.03. So 220. Any questions with that one?
No, I think the confusing part is knowing how to write it out properly. I know what it says, I just think that's where.
The other option that you could do is kind of what he said, but not where he was saying, pick a number. Pick a number for minutes. and try it. So like if you did 100 minutes, you would do 7 times 100, so 700 cents, and then just add that to the $20. It's like, oh, okay, so now just put an M where you put the 100. So that's the thing. It's like a lot of times when you're trying to take a words and change it into a thing, we can do things with numbers really easy. So like if you pick that and just start looking for the pattern of what you're doing, you're always plugging it in the same place, then just put the letter there, and then you have your equation. So, all right, let's put this one in, and then we'll go back and look for some of the other ones that you guys didn't do. All right, so close that. Minimize that for right now. Oh, wrong one. This one. All right, let's look for topics that you guys are struggling with. Remaining. So, you guys got 100 of those, 100. Nobody's done those topics. The word problem ones. No, it's fine. Yeah, they're going to give it to you in order. That's not a big deal. So they typically give you the harder ones towards the end. That's honestly what I'd expected to see. So I'm just looking to see like so. Let's actually do some of those. So we're going to do. Should be fine now. Equations, inequalities should be fine now. We did those. Did those, so let's do this one. All right. All right. So in this one, they're looking for area of a circle, and there's a few different ways for this problem. Actually, we'll just do this one. Area involving rectangles and circles. Yeah. So I'll show you how to do this one. There's actually a couple different pictures that they'll give you. This one's where it's on the outside. They will also have it where it's cut out. So they'll have it where the circles are actually like inside like this. So you can see it either of those two directions. So the first thing we have to do with this problem is find the area of the rectangle. So ignore the circles. What's the two sides of the rectangle? So length times width, we got 50 and 80. So it's just 50 times 80, which is 4,000. That's the area of that. Okay. Everybody get that part? All right. The circle is 3.14 times radius squared. So in this problem, my radius is half of the 50. So it's 25. 25 squared. So we're going to do 3.14 times 25 squared. And we get 1,962.50. Okay. We good to that point? Almost. The last step on this topic, you have to put those two numbers together. And this actually is, that part's actually the easy part. Putting them together is actually the hardest part because it depends on the picture. So this picture, I have the entire circle and it's on the outside of the rectangle, correct? So I'm going to add those two numbers. So I'm going to do 4,000 plus the 1962. So if it was on the inside, I would have subtracted them too. And if I only had half the circle, I would have taken half of the area of the circle. So if I only had one half of the circle, I would just cut that area in half for the circle, and then I would do the same thing, either add it or subtract it. So in this case, it's 5,962.50 meters squared. I'm adding the 4,000 times the 1962. Yeah, because it's the rectangle plus the circles on the outside. So like this picture right here, I would do the exact same thing, except this time I would only take half the circle. So I'd have cut that number right there in half and added it because it's on the outside.
Yep.
I want one. Let's see if they give me one. Yep, like this one, same process, but it's cut out. So I would have done it and I would have subtracted the numbers because it's cut out. See how it's cut out of the rectangle? This one's one, but the beginning step, this step, is the same for every one of the problems. Okay, area of the rectangle, area of the circle is the same process for every one of them. You just have to look at the picture and see how you're going to put those together. And everyone, unfortunately, varies. They're always going to give you the diameter in this topic. So, yeah, so you're always going to cut the diameter in half. So, all right, let's do. I just did that one actually. Did that one.
So the question of that last one was what the area was altogether.
Yes. Yep. All right, let's do this one. So the lab, in the lab, Rita has two solutions. So this is a mixture problem. And while this one sounds really complicated, it's not that bad. So just work with me and I'll show you the tricks to these. So Rita has two solutions that contain alcohol and is mixing them with each other. Solution A has 60% alcohol. Solution B has 10% alcohol. She used 600 milliliters of solution A. How many milliliters of solution B does she use if the resulting mixture is a 40% alcohol solution? Okay. So all right. So when we're looking at this, when we add mixtures together, it's going to change my percentages. So I have 60% of A plus 10% of B is going to be 40% of some new solution. Right? Everybody understand where that came from? 60% of A, 10% of B is going to give me 40% of some new solution. Yes?
Yes.
There? Okay. That's actually the hardest part. All right. We know how much of A, right? A, so I'm going to change these percents to decimals to make my life a little bit easier. So that's 0.6. And I know that's times 600. Plus 0.1 times, actually I'm gonna leave it B, times B, right? We good so far? Equals 0.4 times 600 plus B. So now here's the $1 million question. Anybody understand where I got the 600B plus B from? Not you.
It asks how many milliliters of solution B result in interest 40%.
Yeah. So why did I put 600 plus B?
It says she uses 600. Oh. Sorry.
That's okay.
See?
Yeah.
You see?
But then I figured if everyone's gonna be confused, that's where you'd be confused. Why? Okay. Remember what I said. Word problems are realistic, right? Okay. So if I had 600 here and 100 here, how much total did I have? How much total solution did I have? Right, which is what? Right, what did I just do to those two numbers? Right, which is why I'm putting it out here. If this was 200, it'd be 600 plus 200, which would be 800. Okay? So think realistically. If you can't figure out where it is coming from the letters, put a number in there and see what happens.
So it's supposed to be 600 plus.
Right, because, well, I have to solve this. I have to finish doing the problem. But
Yeah.
the goal is they need to know how, I have to multiply this by how much solution I have. I don't know how much solution I have because I don't know B. But if I did know B, I would literally have added those two to get the total solution at the end. I have a cup of water here and a cup of water here. If I put them together, I have 2 cups of water, right?
But is that supposed to be 700 then?
No, we don't know what it is yet. What I was saying was you could pick a number for here just to figure out what you would do
Oh.
to this problem.
Because they don't accurately tell you what B is.
Because, right, we don't know what B is. We have to find it. Now let's go through and do our problem. What's 6.6 times 600? What's 6 times 6? So it's 360. Plus 0.1B. 4 times 6? So it's 240 plus 0.4B. Next step. Which one am I moving? The 0.1. So I got 360 equals 240 plus 0.3B. Next. Yep. So I got 120 equals 0.3B, and then divide by the 0.3. So I don't know this off the top of my head.
Yeah, divided by decimals.
120 divided by 0.3, 400.
Divided by decimals.
So that's 400.
It is possible.
So it was 400 milliliters of solution B. The other part with word problems is your answer should make sense. Okay? I started off with 600 milliliters of 60% solution, right? And I want 40. Is 40 closer to 600 or 10? Forty is closer to 600. I mean, sorry, let me rephrase. What I totally missed the wrong number. Is 40 closer to 60 or 10?
Yeah.
The 60, right? It's closer to the 60% solution than the 10 solution.
Yes.
So this number should be less than the 61 because I'm going to have more 60 than the 10. So if you get a number that's bigger than 600, you know you made a mistake somewhere in there. So that's the thing. Once you get your answer, think realistically about it. Does that answer make sense? Okay. And it's like, and there's their crazy explanation of it. Same answer, same steps. I like my solution better. All right, so let's see. Here's the other mixture problem they give you. At a movie theater, child's admission is $5.70. Adults are $9.60. So C is 570. A is 960. 4 times as many adults' tickets were sold as child's tickets. So 4 times C equals A. Okay. So now, does everybody see where I got the 4C equals A? Because if you read it, what would you have put? It says 4 times as many adults' tickets as children's tickets were sold. How many of you would have put 4A equals C? This is 4 times the adult tickets. Okay? Very, very common mistake. This is where thinking logically and thinking about the word problem helps. If it says 4 times as many adults' tickets as children's tickets, which one's going to be bigger, adults or children? It says 4 times as many adult tickets as sold as children. So I'm going to have more adult tickets sold than children's tickets. So my number for adults has to be bigger. So if I did 4 times A equals C, C would be bigger. So it's that process when you're thinking about it. Total sales was $882, and that's it. So my child's tickets were $5.70, so $5.70 times C, plus $9.60 times A equals $882. But now I know that 4C equals A, right? So I'm going to replace that A. So I have 570 C plus 960 times 4C equals 882. So that comes from that. Remember, at the end of the day, I'm not expecting anybody in here to get 100% of every single topic done. So there will be topics you just don't get. Just like every other math class that you've ever been in your entire lives. You never got everything right, including me. Okay. So I was not the perfect student that got everything correct. I was the one who told the teacher they were wrong. So, all right, so we got to get rid of parentheses first, correct? So 570C, what's 960 times 4? 36 plus 2, 3840?
Yeah.
Now, those both have C, right? So we can put them together. So 43, 4410. And divide by 4410. So C equals 20, I think. Somebody want to do that real quick for me? I think it's 20. Okay. So we sold 20 tickets for children. How many adult tickets did we sell? Remember, adults was 4 times that, right? So adults was 80 tickets. The other thing that I did here was, notice I did not use X and Y. Okay. I used A and C. So when I did my work, the answer I know where I'm putting things in. Okay, because I think in this topic, Oh, they actually are just asking for the number of children tickets sold, but so you'll know exactly which number. When you get the number, you'll know what it means. When people use X's and Y's, they sometimes, when they get to the answer, they forget which one was which, unless you write it down, which most people don't. So using the same letters that actually make sense for the problem definitely helps you. Okay. All right. I don't see a crazy problem with all letters. I could be totally wrong, but I don't see one. Oh, wait. Interesting. I gotta see. I wonder if that's just a prerequisite that's not in here. Hold on. Might be. Oh, actually, hold on. I can just do it this way. What's your last name?
You're gonna look through topics.
Hold on. I'm just gonna pull up your topic. I'm literally gonna do that. No. There we go. No, I'm trying to find that one topic that she keeps messing up on. No, it's fine. The wonderful thing is I can see all the stuff you've done. This one. Here we go. All right, found it. Oh, okay, so it is solving a variable in terms of other variables. Okay. That's it. It's a wonderful thing. Because in essence, I know why. I gotta see if I can find one real quick. But now that I know the topic name, I can. No, not necessarily. Solving. No. All right, I'll just make one up. I know what it is. I can't seem to find it, which is fine. All right. So the topic that we're referencing is this. So it's like they'll say solve in terms of u, and they'll give you u plus m equals c, for example. So we're actually going to do this exact same way you did the actual solving equations. My goal is to get that by itself as a u. So what do I got to get rid of? Right, so I'm just going to subtract m from both sides. So the u comes down, that's gone. I can't put this together, so I literally just rewrite it. So the only difference is you can't actually put them together, so you just rewrite it. So it's c minus m, and that's the answer. That's it. And actually, if we want to do a little more crazy one, like, so if you had like that, that's the slope, the Celsius problem. Wait, do I have that one
Yes.
backwards? So yes, you double it and add 32, yes. All right, so I want to get C by itself, right? That's my goal. I want to get that by itself. So what's the first thing I got to do? I want to get rid of this 32. So I have F minus 32 equals 9 over 5C. Right? And now I want to get rid of the 9/5. So this is the one where you flip it over and multiply both sides. So I'm going to multiply this side by 5/9 and that side by 5/9. So the answer is 5/9 parenthesis F minus 32 equals C. And that's the answer.
Wouldn't that technically be called reciprocal?
Yeah.
Except I keep remembering that when you do reciprocal, you're also flipping the sign, like from positive to negative.
No, that's inverse. So that's, in essence, all you're doing. The hard part is what people get confused is because normally when you move things over to the other side with numbers, you're putting the numbers together and they're gone. Or you're putting them together so you only have one number. Since we're doing it with letters, you just rewrite it.
Yeah.
So I honestly, this is probably the absolute, they're never going to even give you something like this in that topic. That's harder than anything they're going to give you. But you can see the process and steps are exactly the same. Yeah, letters letters are the ones that make everybody go, letters. Get used to them. It's algebra. They're not going away. They are not going away. All right. Other than that, we are done.